Hello and welcome to Accenture On Air Digital Transformers podcast series. Change is everywhere around us, it is part of our everyday life. Technology evolves rapidly in the industry sector, and innovation around connectivity, artificial intelligence and machine learning offer new possibilities around manufacturing and process control. This podcast series will involve industry experts, leaders in strategy, business intelligence professionals and innovation, and change creators. We will discuss delivering digital transformation at speed, scope and scale, addressing the most complex and critical challenges by using the right technology and accelerating change across enterprise. My name is Marinel Moraru, and I'm an expert in industrial connectivity and process control. I will be your host for this show. In the previous episode, we discussed cybersecurity, crucial component in the future's digital factories. Yes, I said future, but what we discuss here is not so far away, it is happening as we speak. That's why I invited for today's episode my colleague Radu, who is a business development manager working with various clients to identify projects around digital manufacturing. Radu, please tell us a few words about yourself and what you do.
First of all, thanks for the invitation. Very happy to be here and discuss the topic with you. Also in a podcast, not only on the hallways. So a few words about my background. I have approximately 12 years of experience in various industrial environments. I started working in manufacturing and I've tried a couple of roles from manufacturing to engineering, design, automation, project management. And now for approximately 3 years I work in digital transformation. I know this is a key phrase nowadays, digital transformation, but I hope that during this podcast we will explain a bit what it means.
Well, yeah, that's the whole idea. Thank you for the introduction. And now that you mention it, our topic for today will be the digital factory and what it is. What is a digital factory? And my first question for you is, in your view, what is a digital factory?
Digital factory, digital transformation, these are all buzzwords and lots of people talk about them. I like to keep it simple, at least in my head, and try to visualize what a digital factory is. And in order to do that, I imagine myself that this digital factory is like a pyramid. And you start from the base of the pyramid with all the machines that are part of the manufacturing process, and you have a couple of layers until the top of the pyramid, which represents the business logic. Commonly in the majority of or in many manufacturing plants, with these machines there are some sensors, some PLCs, and in some cases these PLCs are centralized and have a common brain, a common control. In almost all the cases, this brain of the machines remains there in the shop floor. So all the information, all the data of what's happening in the factory is actually trapped there. And then we have in another building next to the factory, in the admin building for example, we have where the business logic takes place. So we have the client's database, we have all the orders coming in, we have a procurement process, we have production scheduling, and what happens nowadays, or in the past more, is that these are separate and disparate processes. And through a digital factory we have to connect all the bits and pieces which take part of getting an order from a client till delivering the product. So it's a bit more than what usually people think of.
Another buzzword will be the IT and OT. So what you said in the beginning is the OT, the operation technologies.
Yep.
Whatever happens on the shop floor. And the second part is what happens behind inside the IT networks, where we have the business layer. And now those two separate words are converging, and that's the beginning of a digital transformation.
Exactly, very good point, and this is a good way to define what Industry 4.0 is. So OT, operational technology, all that, PLCs, and IT, what is server, what is everything related to servers, infrastructure, applications, and software solutions. Now that we've created a bit of a big picture of what's happening, As I see it, the first step would be to lay a foundation ground which connects this shop floor with the ERP. And usually this is done through an MES. MES, it's the acronym from Manufacturing Execution Solution System. And this software application, because this is a software application, connects to all the machines, gathers data from all the machines about the manufacturing process, about how many workstations are in the process, about what's happening on each workstation, what's the raw material going into the workstation, what is the output, what is the overall equipment efficiency. You can have also instructions for the worker in each of these steps. And when you have all this data already in a digital format, it's very easy to connect it with the ERP. So now instead of getting a printed file, so a piece of paper, or send an email with an order from the office to the production manager, to the planning manager, everything is automatically in synchronization with this system. So this would be a first step as I see it.
So the goal is to have a paperless shop floor.
Exactly.
One of the goals.
One of the goals is to have a paperless shop floor and to have a single source of truth. So there is a single point from everybody gathers and sends data in.
In my world, so I'm coming from the OT, and we call it a unified namespace, a place where every piece of data can be stored and can be accessed from one single source. Yeah.
Yep. And with this unified data, we also have a very good and concrete traceability. We know exactly what happened with each of the product across the entire manufacturing chain. So this would be a first step. A second step, there are other IT solutions which are being implemented in factories that are helping the manufacturing process. And one example would be PLM. This is the acronym from Product Lifecycle Management. This kind of solution is applicable for complex engineering processes. Let's take a plane, for example. In a plane we have millions of components, and with the help of this software you can easily identify the approval process from the inception of the design till the manufacturing. So you can see exactly what modifications were performed, by whom were they approved, whether they were implemented or not. And this software is not something new. So this is on the market since 20-25 years, and I think it started in the aero and defense industry. But what is new is that we need to integrate this PLM with the MES, so with the execution part of the business. So PLM is responsible for design, engineering and research and development, MES for manufacturing. So we bring these two pieces together. Then we have other solutions which are responsible for planning, advanced planning and scheduling. Here we gather all the resources from a manufacturing plant or factory, and we are able to create a real production planning based on all the availability of resources and the requirements of the clients.
I just wanted to ask to complete something on the PLM. Having a connection from the PLM to MES, that will close the loop actually. When something happens on a product or finished product, if a change needs to be done, it will be automatically updated in the manufacturing side. So somehow this closes the loop in between the end product, the finished product, and the production of that product.
Yep, and this opens the door for digital twin, another buzzword that we hear a lot nowadays. Digital twin can be applied in at least two aspects. One is the digital twin of the factory which produces the good, and then it can be the digital twin of the good of the product itself. When we think about digital twin of the manufacturing location of the plant, imagine that you are designing a new product from scratch and you have the blueprints ready, you have the raw material. Normally what you would do, you would start by doing some physical trials of the product, and then you adjust the engineering in order to reduce the material consumption, in order to improve the product, in order to be more efficient in the production process. So you have these iterations when you start a new product line. With this digital twin, you can do all these things in a simulation environment where you have almost no costs at all. Because this digital twin, it's a one-to-one replica of your real manufacturing process. And each time when you try to create the product, you see what was wrong, you improve it without spending anything.
Or the spending is quite low. It's lower than testing on the real product. Mm-hmm.
And then we have the digital twin of the product, and this is very important because you have all the traceability of how that product was designed. It is very convenient for traceability purposes and for maintenance. So just to go back to the big picture, because now we just scratched the surface, and it may sound like it's a bit superficial because all of these subjects are very, very complex and detailed, and we want to address the topic in 15 minutes. Ish. So just to go back to the big picture. So now we have the foundation, which is the MES that interconnects the shop floor with the logic business, and we have lots of other softwares interconnected with this backbone. Like I mentioned, planning, quality, warehouse management, inventory, you name it, whatever is in a factory, it can be, and it should be in a digital factory, it should be captured in this model. So if we have all this data, we have to harvest it somehow. At the moment it's trapped. It's a trapped value because usually it's not being used. So just to mention a couple of cases that I was thinking about to be discussed with you now.
You said about, you have data, you mentioned maintenance, and I'm just thinking that it's also part of this. We can mention that we have AI that will be used, so artificial intelligence. We already have a lot of applications where we see machine learning, especially in computer vision. Well, that's the easiest example that I can then bring, or predictive maintenance. You just follow the temperature trend, and if something doesn't follow the rules that were already studied over the time, then something will change, or a trigger or message will be sent to someone who can look at the process, what's happening. So also these kind of applications are, yes, we speak about buzzwords, but they are already there, they are in place, and we see them on this future work shop floors.
Yep, you already mentioned some of the cases I was thinking about, and you added some technologies that are being used in order to produce these use cases. And with the predictive maintenance, I'd like just to go in a bit more detail. Why is this so important and what it means? Imagine yourself that you are the maintenance manager of a large manufacturing site, and you have, 300 electrical motors on the shop floor. And historically or normally you are doing scheduled maintenance for each of these motors. How it would be if you would have a screen, and each time when a problem may occur, you get an alarm with exactly the engine that may have a failure, and also with what kind of failure it would be, and with the likely time frame of the failure to happen. So this would help you a lot.
It's easier to plan ahead.
It's easier to plan ahead, then your cost for maintenance would be lowered automatically because you do not exchange parts which are still functioning properly. You do not have production stops. I think this is the most important advantage, because you always have all your equipments in good condition.
I always, I think I mentioned a few times in my discussions with the clients and in applications that the first step towards a digital transformation is having the KPIs like OEE, so key performance indicators, like OEE, overall equipment effectiveness. It's a bit hard to speak without acronyms, but it is what it is. and having the OEE in place and showing you how your machinery works and what's the availability, for those machines. That's the first step into this direction of doing a digital transformation, because it doesn't make sense to invest in everything else on top of it if your machines, your tools on the shop floor are not reliable and you have a lot of maintenance issues.
Yep. Another use case interesting where AI and machine learning is being used, and it's already a reality. Dynamic production scheduling. So this is about how you are planning your production based on all the available resources, and this is done automatically. And why it is dynamic? Because it comes up with solutions each time something unexpected occurs. So something unexpected may be lack of raw material, or higher priority for a certain order, or you have a machine breakdown on the production line. So each time this software using AI is proposing you the best solution with the available resources. And this is not future, this is already present.
Yeah, it is.
Another point could be AGVs, automated guided vehicles. So these are vehicles which are going to the warehouse, are picking up the raw materials, and are bringing the raw materials to the production line. And everything is picked up automatically. The inventory is decreased automatically. The MES recognizes that it has a raw material input in the system, and it goes to the right flow. All these use cases are creating the digital factory, the full digital factory.
You know that we have this quite close to us here in Romania, on a shop floor that has this kind of HVs, MES connectivity, and MES platform.
I think this is a very good story, yeah. And maybe you should give a few details about that, because it's public. And
well, considering the time, I will do it in one of the next podcasts. I will go in more detail now. It was just a hint about that. That we have here in Romania, we have one of the most advanced washing machine factories. So that's an interesting story, and I think it deserves its own.
And just as a
episode.
teaser, this factory has received the World Economic Forum Lighthouse Network Award, which is a very special prize given only to a handful of factories across the globe.
10 different
like that,
factories across the globe. Yeah. But yeah, I will bring it up in one of the next episodes for sure.
So I guess we have to wrap up, right?
Yep,
just
sure.
Let me have one more sentence and then we can close. Full digital factory, what it is. I hope I've been able to paint a high-level picture of how I see it, and the final goal would be to have a lights-out manufacturing process. This would be a full digital factory for me.
That sounds interesting. I give you another 2 minutes to give us more info about that.
This is a philosophy, and I think it was, I'm not 100% sure, but I think it was already partially implemented in a factory in Germany as a proof of concept of a completely automated factory that can run with the lights out. This is from where the name comes from. So it doesn't need any, or it needs very less human intervention. And the factory can operate 24/7 with the lights out because no light is needed. Human intervention is needed only once in a while when maintenance may be needed. Mm-hmm. And it's completely autonomous in the way that also when the inventory is near depleted, the factory knows how to launch a new PO, a new purchase order to the suppliers. So also for the supply chain is integrated.
It requests for new materials, for new raw materials, for spare parts. Okay.
Yep.
That's really interesting. Yeah.
But for the moment, I think it's just a philosophy, and what happened in Germany, it's a proof of concept. But when we will be able to bring all of these stories together, and more than this, because there are much more behind of what we discussed today, then we will be reaching a full digital factory.
I don't see it so far away, so it's actually parts of these really big parts are already happening. So I don't see it so far away.
So all of these examples that we were talking today are happening here and there. I haven't seen them all in a single place. And this is why I say that we still have a bit of time ahead of us, but just a bit, until somewhere someone puts all the pieces together.
Yeah. Thank you, Radu, for the insights and for this nice discussion we had. And I will find new subjects for you, and I will we'll discuss more on the future episodes. Thank you so much.
Looking forward to it. Thank you, Marinel.
Okay, bye.
Bye bye.